This is a set of tutorial videos using FLAC3D to calculate the total and effective stresses for a homogeneous embankment dam with rock abutments. This set of tutorial videos provides an extension of the FLAC2D tutorial embankment dam that had modeled the problem to the left. In these new set of tutorials in FLAC3D, a more complex geometry, shown to the right, will be modeled. Note that the geometry of the embankment dam and the stream direction modeled in FLAC3D will be the same as the tutorials in FLAC2D. In addition, the properties of the embankment dam remain essentially the same. The additional geometric complexities that will be modeled in FLAC3D are highlighted here. In this new model, the crest width of the dam will be 3 embankment heights, and the channel width will be a single embankment height. The adjacent rock abutment and foundation will be modeled with 20 feet of foundation rock below the embankment, and 15 feet of rock abutments to the right and left. This set of tutorial videos have been developed to incrementally lead to calculating the total and effective stresses of the complex geometry just shown, and have been broken into 3 parts. In the first of the 3 tutorial videos, the command script in FLAC2D was modified for FLAC3D, and a numerical mesh that includes a 65-foot width of the embankment was used. The numerical mesh of this model, Model 1, was developed with extrusion with sketch set. In this second video of 3, the steps to develop the numerical mesh of the more complex geometry to the right using building blocks will be presented. The numerical mesh for this model, Model 2, will include the embankment with the rock abutments. In the last tutorial video, the numerical mesh for Model 2 that will be created in this tutorial with modifications of the analysis script for Model 1 will be used to calculate the total and effective stresses of the embankment with the rock abutments. Please note that for both numerical meshes, the models have been developed to have less than 1,000 numerical zones and therefore can be completed using the free demonstration mode version of FLAC3D available. We now focus on the development of Model 2. The drawing shown provides the subdivision of the blocks to be used in FLAC3D to model the domain, as well as the number of zones along the edges of the blocks. Please note that without use of the attach or interface commands, the number of zones per block must be the same along a specific row or column of blocks. This is the approach used here. Also note that the row of blocks that correspond to the embankment height, the ratio multiplier used to adjust the zone height with length, is 1.20482 in the vertical direction. This multiplier was chosen so that the bottom nodes of the top row of zones are near the reservoir level for more precise assignment of boundary conditions. For ease of command assignment, it is important to assign zone and zone face groups. The location and names are provided here. It is now time to use the building blocks tool to develop the numerical mesh. The set of graphic-based interactions with FLAC3D to produce a numerical mesh using building blocks will now be shown. A brief summary of the next step of steps using the model window will be provided next, following these graphic-based interactions. At this stage, the zones for the numerical analysis have been produced. Zone and zone face groups will now be assigned with the following graphic-based interactions. The colors of the zones and zone face groups can also be changed. Accomplishing this task is shown using the following graphic-based interactions. The last step of this tutorial should be to resave the state either by overwriting the current file mesh.sav or saving with an alternative name. This completes the second of 3 tutorial videos using FLAC3D to calculate the total and effective stresses for a homogeneous embankment dam with rock abutments. In the upcoming last tutorial video, the numerical mesh created using building blocks in this tutorial will be used with modifications to the analysis script from the first tutorial to calculate the total and effective stresses of the embankment dam with the rock abutments.